It all began with what appeared to be another marine science expedition off the coast of Australia. A group of researchers tagged a healthy, 9-foot-long female great white shark to monitor her habits and migration. It was routine, until she disappeared into thin air. No struggle. No bodies. Only her tracker, which eventually washed up on the beach, provided a clue to the terror that had transpired under the sea. When the researchers recovered the data, they were shocked. It showed a sudden spike in temperature, then a plunge near 900 feet into the depths. It was not random. It was not a malfunction. The shark did not die, it had been consumed whole. Whatever the great white ate had interior temperature significantly hotter than the ocean around it. And it wasn't finished. For days, the tag continued to register motion, tracing out the slow, powerful plunges of some enormous predator. What could overwhelm one of the ocean's most feared top predators so easily, and so quietly? In an environment where the great white shark reigns supreme at the top of the food chain, something had made the hunter the prey. And the further scientists dug, the more bizarre, and frightening, the tale was. It happened in late 2003 off the rugged coast of Western Australia. Marine biologists had fitted the great white with a data logging tag that would track temperature, depth, and movement. The tags typically fall off after weeks of data collection, float to the surface, and transmit their results via satellite beams. All seemed normal for some time. The shark swam according to normal migration patterns, traveling along the southern waters like other sharks that came before her. But suddenly, after 4 months or so, the tag was discovered washed up on the beach. When researchers got the data, it showed a chain of events that defied all reason. The shark, which normally swims in 46 degrees Fahrenheit 8 degrees Celsius waters, was now confronted with 78 degrees Fahrenheit 25.5 degrees Celsius, a huge, unnatural temperature rise for ocean depths. Only a warm-blooded creature could have swallowed the tag at a temperature like that. Then there was the drop. Right after the temperature shift, the tag plunged downward, nearly 1,900 feet, into the abyssal sea. This was not the drift of a dead body or a free-floating device. This was a deliberate plunge. The tag kept moving for days, ultimately surfacing when it was expelled or removed. The implications stunned the scientific community. What predator would attack, consume, and disappear with a 9-foot great white shark like it didn't exist? As information flooded in, one fact was undeniable: this was no accident. The shark did not perish from natural causes. It was consumed. And not simply killed, swallowed whole. Speculation was rampant. Was there a giant sea monster hiding in the depths? Was this the handiwork of an extinct predator from prehistoric times? Had the expedition team stumbled upon evidence of a huge, undiscovered creature? While these hypotheses made headlines and tickled public imagination, the researchers were more practical. They were looking at 2 possible suspects: another, much bigger great white shark, or an orca, or killer whale. Both predators were formidable. Both had a record of brutal encounters. But the data didn't fit neatly with either. At first, the notion that a second great white was involved felt like science fiction. Great whites, after all, are top predators, strong, solitary killers with no natural foes once mature. But the ocean follows hard rules, and to live often means turning against yourself. Great white cannibalism, it happens, is more prevalent than many thought. Certain shark species, such as the sand tiger, start life as cannibals. Within the womb, the dominant embryo will consume its siblings, a survival mechanism called intrauterine cannibalism. It's nature's harsh but efficient means of letting only the strongest be born. Outside of the womb, intershark attacks are less common, but they exist. Great whites, tiger sharks, and bull sharks have all been known to feed on smaller sharks, even sometimes other sharks of their own kind. It's not malicious. It's survival. A smaller shark is simply a meal in the wild. Scientists in South Africa once recorded a colossal great white mauling another in two. In another incident off Guadalupe Island, researchers observed territorial aggression among great whites when they were in mating season. Some attacks proved deadly. Those events, previously thought to be outliers, suddenly became meaningful. The 2003 tag readings reported a harrowing story. The shark was cruising along, until it wasn't. A brief temperature spike, followed by a dive to great depths, then days of gliding slowly and purposefully mirroring the movements of a predator much bigger. When scientists compared the internal temperature recorded by the tag to known sea creatures, the nearest match wasn't a whale. It was another great white. Unlike most cold-blooded fish, great whites are regionally endothermic, which means that they're able to heat up the temperature of certain parts of their bodies such as the stomach and muscles in order to stay active in cold water. This makes them effective predators in warm as well as cold seas. It all matched up: the temperature, the depth, the predator patterns. The path that the tag took was almost identical to other known information from other large, tagged great whites. Squids, whales, and other predators did not fit. Only a single predator did, a significantly larger great white shark. But just how large would the shark have to be? In order to take down a 9-foot shark with one bite, or in one sudden strike, the attacker would have had to be, at the very least, 16 feet long. Maybe longer. That's within the documented size range of the largest great whites on record, some even reaching more than 20 feet. For perspective, that's longer than a pickup truck. This was no fight. This was an ambush. Experts speculate the attack was perhaps driven by territory, mating aggression, competition for food, or plain hunger. A smaller shark in the ocean is a high-fat, energy-dense meal. And survival has no allegiance, no matter what species mates. The 1,900-foot plunge documented in the readings is also in agreement with established great white behavior. Great whites can dive more than 3,000 feet while on the hunt for food or searching for cooler waters to digest. The pattern documented wasn't only feasible, it was probable. The notion that a great white might devour another was bigger than a scientific wonder, it was an epiphany. It dispelled the age-old theory that adult great whites lacked predators. It made scientists rethink the composition of the ocean's food chain. If one shark could accomplish this, what else was taking place in the uncharted abyss? Marine biologists started looking into other similar incidents: lost tags, suspicious vanishing, unusual data trends. And they discovered further evidence of great white cannibalism. What happened in 2003 was not an isolated enigma. It was part of a secret, grisly world beneath the surface. The encounter became the focus of the documentary The Hunt for the Super Predator, tracking marine biologist Dave Riggs and his crew as they hunted for the identity of the elusive killer. What they discovered only served to deepen the chilling hypothesis: in some place deep in the depths, a gargantuan great white had transformed from apex predator into the apex of the apex. Even with persuasive evidence, however, there still existed another explanation. While the cannibal shark hypothesis carried some truth, there was another predator in the sea that was known to challenge even the strongest hunters of the deep: the orca. Killer whales aren't only magnificent sea mammals. They are clever, cunning, and sometimes downright frightening apex predators that hunt in coordinated groups. In fact, in recent years, orcas have earned a reputation for preying on, and killing, great white sharks with surgical precision. The evidence isn't anecdotal. It's been written down. In 2017, 5 great white shark carcasses washed up on South African beaches. Each was missing one thing: their livers. No evidence of a body struggle. No ripped fins. No huge bite wounds. Just tiny, precise wounds around the belly. The verdict? Orcas had committed the crime. Specifically, a couple of orcas known as port and starboard, with their unusual-looking dorsal fins and precision hunting skills. They weren't merely killing sharks. They were culling them for particular organs. Great white livers are extremely high in fat and nutrients and are therefore a very effective energy source. Orcas, with their hyper-intelligent minds and sophisticated hunting tactics, learned that a long time ago. Rather than wasting energy killing an entire shark, they target the best stuff. Some researchers think that the orcas first stun or turn the sharks over with their powerful tails, a maneuver that leaves the shark paralyzed in tonic immobility. Then, with a quick bite, they remove the liver with almost surgical precision. The rest of the shark usually remains unharmed, drifting behind like a lifeless ghost. This chillingly effective behavior is without precedent in the sea. And it suggests something more unnerving: intelligence. On the surface, orcas are a likely suspect in the 2003 puzzle. They're warm-blooded, like the shark that swallowed the shark. They're found swimming in deep water. And they possess the power, numbers, and intelligence to kill a 9-foot great white with nary a break of sweat. But then there is the evidence. The surge in temperature within the predator that consumed the shark was 78 degrees Fahrenheit 25.5 degrees Celsius, in line with the body temperature of a great white, not an orca. Orcas, being all mammals, maintain a body temperature nearer to 98.6 degrees Fahrenheit 37 degrees Celsius, much greater than what the tag registered. That alone places heavy skepticism on the orca hypothesis. There is also the attack methodology. Orcas are methodical predators. They hardly ever, if at all, swallow major prey whole. Rather, they target specific organs or rip their victims apart with coordination and strategy. The 2003 attack wasn't that. It was quick, vicious, and overpowering, an ambush. The tag didn't register any thrashing or spasmodic movement before being swallowed, only ordinary movement, a sudden spike in temperature and plunge. That sounds like a great white shark attack from the bottom, stealthy and explosive. Not the deliberate, coordinated attack of an orca pod. So, yes, orcas are more than capable of taking out sharks, but the method and temperature information indicate they weren't the guilty party in this case. The enigma remains unrevealed. Was it a giant cannibal shark? A rogue orca that bucked the norms? Something else? Nothing in the years since has repeated the same profile of the 2003 occurrence. But its eerie statistics remain fascinating to marine biologists, cryptozoologists, and curious brains everywhere. It remains a grim reminder: we still do not know nearly as much about what lies beneath the ocean's surface. The ocean is huge. Enigmatic. Mostly unmapped. And as this case illustrates, sometimes the apex predator isn't what we imagine it to be.